Hi. In this chapter of the book, we look at tools that any forecaster should have in their toolbox. Hence, we call this the forecaster's toolbox. We use these tools, what we're going to learn in this chapter for the rest of the book. Now, before we get to these tools, in this section of the book, we'll outline the actual end-to-end process for generating a forecast. Hence, we're going to look at a tidy forecasting workflow. So the process of producing forecasts can be split into a few fundamental steps. Now, the first step is preparing the data. In this book, we do a little bit of that, but most of the data we look at is sort of already wrangled, already shaped, already in a table format. So we don't do too much of it, but there is some of it. The next step is to actually visualize your data, and we spend the whole of chapter 2 on this and some of chapter 3 and chapter 4. Well, the next two steps is to specify a model and then estimate a model. We're going to start learning about specifying a model in this section. Once we estimate a model, we want to evaluate how good this model is. And to evaluate, we will look at accuracy measures that can help us evaluate the model's performance in forecasting. Once we're satisfied, then we're going to generate forecasts. Well, in a workflow diagrammatical sense, again, we start with tidying our data. Then once we've tidied it, we look at our data, we visualize our data to identify various features. Then we specify a model, we estimate the model, and we evaluate how good the model is. Now, sometimes and many times we might not be happy with the model, hence we need to go and re-specify another model. Or we might specify 3 or 4 different models and evaluate all of them. So this circle here may be visited. We may loop this a few times before we are ready to generate forecasts. Well, let's have a look at an example, at a specific example. We're going to use the global economy table, and let's do some tidying. So the global economy table has GDP, contains GDP and population. What we are interested in is GDP per capita. So we're going to mutate and generate a new variable in which we're going to divide GDP by population. From this table, we're going to select year, country, GDP population, and GDP per capita. So here's our table. It contains 5 columns, 15,150 rows of yearly data. It's got one key variable, and this is country. So it contains time series for 263 countries. Here are the variables: GDP, population, GDP per capita. Let's have a look at visualizing this data, and let's use one specific country as an example. So we're going to filter Sweden, and we're going to look at GDP per capita for Sweden. And we're adding some nice labels to our plot. So what do we see here? We see that GDP per capita for Sweden has got an upward trend. It's yearly data, so it cannot have a seasonal component. And that's about it. So we visualize the data. Now, once we visualize, we're going to go next and specify a model. The model we're going to specify is a linear model using time trend. I'm not saying this is the best model you can use for this time series, far from it. It's just an example that we're going to use in this for the purposes of demonstrating model specification and estimation. So this is the model, just notationally. So YT is equal to an intercept plus a trend plus epsilon t, where epsilon t is normally distributed 0 sigma squared. So what do? We take the GDP per capita. This is the variable that we generated in the previous slide. Let me just recap that because I didn't say it. GDP per capita is the new variable. So this, table. So this table contains these variables. So we're going to pipe this new table, the GDP, in the model function. This is the first time you see the model function. Actually, that's not true. If you looked at the composition, you would have used the model function there. But here's another use of the model function. So within the model function, we're going to select a TSLM, which is a linear model for time series. Our Y variable is GDP per capita. Our X variable, if you want here, explanatory variable, is a trend, which is which actually captures the time trend. Now, notice here, we're passing a symbol into model function and we get this fit element. This fit is a Mabel. What is a Mabel? A Mabel is a model table. Hence, we have this table here. It contains 263 rows, 263 variables or key, 263 countries for that key. For each row, each row contains an estimated model for that country. So we have 263 countries. The actual model function is estimated a TSLM, a linear model for time series for each country. The next step is to evaluate. We're going to skip a little bit this evaluation step. We're going to revisit it in further subsequent sections of the chapter. But what we're going to do now is generate forecasts. So we take a Mabel, the fit object here, and we pass this fit object into the forecast function, and that generates a fable. What's a fable? A fable is a forecast table with point forecasts and distributions. So there's two reasons why we call this a fable. So a fable is similar to a forecast. It tells you something about the future that is not true, but it is informative about the future. Very similar to what a forecast is. Now, just a comment here that for the forecast horizon, we can use strings here, which is useful, especially when we go to higher frequency data. If you have, I don't know, if you got daily data and you want 2 years worth of observations or 2 months, it will be useful. Or you can use numericals in here directly. So you can say H equals 3 and that will be enough. We recognize that it's annual data, so we'll generate forecasts for 3 years ahead. So what do we see in the fable? So again, for each row, what do we see in the fable? Let me repeat that. So this now has 789 rows. It has 789 rows because we have 3 forecasts for each country. So 263 countries times 3, 789. So row 1 has got H equals 1 step ahead for Afghanistan, H equals 2 steps ahead for Afghanistan, 3 steps ahead. The next 3 rows are forecast for H equals 1 to 3 for Albania, and so on. We see, let me repeat that a fable contains the distribution. Remember, a forecast is a whole distribution, and a point forecast is some point that we select from that distribution, usually the mean. So the distribution, our forecast distribution is normal with mean and variance, and this column also gives you the mean, which is sometimes useful. Let's have a look at some visualization, and if you want a little bit of evaluation, it's a visual evaluation. We're going to do much better in subsequent sections of the book in terms of evaluating how good our how good are the forecasts that our model generates. So basically, from our fable, we're going to filter out Sweden, and we're going to plot our forecasts, and here are our forecasts. Okay, we'll talk about what these actually are in subsequent sections of the book. Just to recap, the process of producing forecasts can be split into a few fundamental steps. Preparing our data, hence in our framework here, in our tidy framework, is generating, wrangling, shaping our data into a symbol. We visualize our data. Once we visualize, we specify and we estimate a model using the model function. So piping a symbol into model gives us a Mabel, a model table. We evaluate the forecast performance, the forecast accuracy of our specification, and we generate forecasts using the forecast function. Hence, taking the Mabel and piping that into the forecast function gives you a fable.